What's going on, everybody, and welcome back to another Granularity.ai tutorial. Today, we're going to talk about using agents to create an information flow diagram process. So the agents that are going to be used in this development is going to be a diagram creator agent, an architectural expert agent, an engineer agent, and a critic agent. Now, there is one agent that I forgot to include in this little slide, and that is the executor agent. This agent is responsible for executing all the code that's going to be written by the engineer. So before we jump right into it, if you like what you're hearing in terms of this little project that I've created for you guys, please smash that subscribe button. Please make sure you like or dislike this video, and please make sure to leave comments, suggestions, and feedback. Any piece of that will help me greatly in figuring out and deciding what content to show you guys. It also pushes my information out there to the algorithm so that you get stuff recommended by me for days to come, just to kind of get myself into your algorithm as well. Um, but anyways, without further ado, let's kind of jump right into creating this AI agent process. So first we're going to go to this project. Now, as you can see, I kind of already have a bunch of packages kind of already installed. A lot of AutoGen packages. We see PyFlowchart here. We see Matplotlib. We see Pill. We see Thermocode. We see GraphVids. Now, my plan for this is to mainly use Matplotlib to create the graphics for this. Now, I will say that sometimes with these AI agents, it doesn't get it right the first time. You kind of have to tweak it a bit to make sure that it's able to get it to exactly where you want it to be. But the main idea is kind of making sure, rather than us kind of creating these diagrams ourselves, having the agents do it for us. So before we start coding out that, let's kind of make sure we import all these packages. Let's do it one more time. There we go. Make sure you have this configuration list created. This configuration list has the OpenAI API key that you're using, as well as the models that you plan on using. Very important when using AutoGen. I don't think it's so important using Crew AI, but for AutoGen, it's pretty important. Great. So now let's first begin to create the user proxy agent. This is going to act as the admin that we're going to use to communicate to the agent. So we have user proxy equals autogen dot user proxy agent. Name equals, let's do admin with a capital. Now, this is a copy of a past project. So I am going to kind of copy and paste the system message just so that I don't have to type it all out and kind of spend a whole bunch of time doing that. So for this admin, the instruction for this is, give me a second. A human admin interact with the diagram creator and the architectural expert to discuss the information flowchart diagram. Diagram execution needs to be approved by the admin. So this kind of safeguards, like, if any kind of before the diagram can be executed, we want to make sure that we see it, make sure that it's approved, and make sure that we can offer our input to it to make sure it all runs smoothly and to get what we want out of this. So anyways, that's the user proxy agent. Next is the diagram creator agent. And this is going to be an assistant agent. So we want autogen dot assistant agent, boom, name equals diagram creator. Nice. And then for this system message, we want as an expert in generating creative information flowcharts, and I'm going to add one more piece, software architectural diagrams, you will recommend Python packages and methods that the engineer should use. The diagram should be insightful, clear, organized, and proportional. So that's kind of the system message that I came up with. Again, depending on what you want when kind of building these agents, you kind of want to add your own spin on it to get what you want. This is kind of just a bare bones way of creating something simple. Even the example I'm going to show you of the agent creating the diagram itself, that itself is simple as well for this tutorial. Architectural engineer is going to be next. I think that's how you spell architectural. And this is also going to be a AutoGen assistant or assistant agent. And then we want name equals architectural expert with system message being as technical as as a technical expert in software architecture diagrams, you will recommend methodologies and ideas to the diagram creator to follow. Do not code. We do not want any other agent coding besides the diagram creator suggesting the packages and whatnot to use, as well as the engineer. We don't want any other agent coding. We don't want any other agent kind of suggesting packages. That is strictly for the engineer and the architectural expert, or architectural engineer, sorry. Architectural expert, I'm sorry, not engineer. Let me fix that, expert. There we go. And now let's finally hit the engineer. AutoGen, boom, dot, assistant agent, name. You don't gotta name this anything important or special, but just engineer. And now let's do system message. This system message is probably gonna be the longest out of all of them. Let's see. This, boom, boom. Engineer, you follow an approved plan by the diagram creator and architectural expert. You write Python shellcode to solve tasks. Wrap the code in a code block that specifies the script type. The user can't modify your code, so do not suggest incomplete code which requires others to modify. Don't use a code block if it's not intended to be executed by the executor. Don't include multiple code blocks in one response. Do not ask others to copy and paste the result. Check the execution result returned by the executor. If the result indicates that there is an error, fix the error and output the code again. Suggest the full code instead of partial code or code changes. If the error can't be fixed or if the task is not solved even after the code is executed successfully, analyze the problem, revisit your assumption, collect additional info if info you need, and think of a different approach to try. So this is kind of the longest system message that you're going to kind of encounter in this tutorial. Only to kind of safeguard how, let me see, only kind of safeguard kind of what this AI agent is capable of doing, telling you kind of, or only, establishing guardrails for what it can and can't do. I think if you are going to develop agents, it's kind of difficult to find that. It's kind of difficult to find that sweet spot that doesn't limit the agent too much, but allows the agent to also explore and do what it can to kind of solve any issues. That's one thing that I've had trouble figuring out over time that I've kind of been exploring AI agents. So this is the executor. Now this is what I was referring to in the slide of the executor is the main agent that is going to be executing the code that the engineer creates. And so in this system message specifically, we're going to have executor. Execute the code written by the engineer and report the result. Human input mode equals, we don't ever want to get in the way of the executor. We want the executor to simply execute the code. That's it. We don't want to stop it. And we don't want to kind of add any edits to it. So last and messages, boom, 3, work, use Docker, false, boom, boom. And then for the last agent we're going to create, that is the critic agent. So this agent, I think, in my mind, at least in how I think of it, is the last safeguard to make sure everything is correct and everything is done as um, the admin asks or wants. The admin meaning you. Um, so I believe the critic is probably your best friend, to be honest. System message. And then let's do, I'm gonna copy and paste this real quick. Oops. Now let's remove this one. So for this agent, critic, double check code and diagrams from the engineer and diagram creator and provide feedback. Please make sure all graphics and images are formatted correctly. And then let's do this as well with the LLM config. LLM config, boom. And now we get to the final pieces that we need to add. Next is establishing the group chat. Group chat equals autogen dot group chat, boom, boom, agents equal, boom, boom. And then we want to add the user proxy, number 1. User proxy, diagram creator, architectural expert, engineer, executor, and critic. Ooh, not the 0. And then we want messages, boom, with max round of 50. And then we want to set up the manager here. Manager equals autogen group chat manager, boom, group chat equals group chat, LLM config. And then here, the final piece, user proxy. This is another user proxy that basically takes in a message of initiating the chat so we can kind of get things rolling. Boom. And then here, so for this message specifically, this was going to be fairly simple. Now, again, you can make the steps for this AI agent to follow as robust as you want. I think for the original project that I did this for, I think there was about 8 different steps that I needed to document, and it was able to do it. It was a little bit complex, but I kind of needed to do some tweaking to the diagram creator agent, I think, and that kind of helped with how it was able to adjust the output. Now for this one, this is the first time I'm actually exploring this message. For this one, we'll see how this goes and what it outputs. But either way, I think if we encounter that it kind of is running into some issues, we can definitely adjust it as we go. But let's kind of run all of this to make sure it is good to go and no errors come up. Nice. Now let's begin by initiating the chat, and let's kind of open this up so that you can see. And this is where it begins to start. So there's a diagram creator suggesting creating It suggested graph, viz, pi dot, but we want to use matplot. Matplot is easier. For a lot of these other packages that it suggests, you may have to install other dependencies. As you can see, dot not found in path, blah blah blah. Install graphics, and now it's gonna try graphics and see what happens. But now that it's hit the admin, we're gonna suggest, rather than doing that, we're gonna want to suggest or use matplot. Now, as you can see, to create a clear, insightful information flow diagram given steps, I recommend using the following Python packages methods: graph, viz, pi dot. It's not recommending matplot, but we know about other packages outside of whatever it's suggesting. So we're going to go ahead and use that instead. And here are the critic: node positioning to improve it, node labels, adding labels, edge styling, diagram. Overall, the code provided is a good starting point. Based on the feedback, here are some additional methodologies: consistent node size, color coding, grouping, annotations, feedback loop, version control. Good ideas from the architectural expert. But now, as the admin, we want to say, please use matplotlib, and let's see what it creates. So the diagram creator is thinking, it begins to use matplotlib as PLT, as we have it defined in the packages already. The code general horizontal flow chart, represent information flow, critic already provided some color coding, annotation, and strength, custom markers, line styles. Okay. Please proceed. Let's see what happens or what its response is. Engineer comes in. Okay. And let's see what we have here. So as you can see, boom, user expresses command to app, application produces an output, output is sent back to user. Now, obviously, this is a pretty simple way of creating a information flow diagram. Now, you can also ask it to make it simpler, make it more complex. Maybe let's try and say, like, make sure the output is sent back to user in the diagram. Let's say show that in the diagram itself. Please show in diagram that let's make sure we copy it first. This is a good diagram. Please modify it to show the output going back, or output being received by user. Let's make sure our grammar is correct. That's what we read over. This is a, why is it? There you go. This is a good diagram. Please modify it to show the output being received by user. Let's see what happens. So diagram creator is thinking again. To modify the flow by user, we can update the visual by adding additional step in the process. Here's the modified code using matplot. Let's see. Please proceed. And here comes the executor. And here we go. The user expresses command to app, application produces an output, output is sent back to user, user receives output. Now, obviously, again, I just added this piece to just show that the user receives the output. But again, you can maybe say, oh, I want to add a line representing going back to the user, or an edge going back to the user. I want these nodes included in it, so forth and so on. And kind of, again, editing as you go. I'm not an expert at flowchart diagrams. I developed a few for the applications I've developed in my time and in my day job. But they're usually pretty simple unless the user asks for something more complex. Then I might have to reach out to somebody. I might have to go to other um, tools and platforms to kind of create a better flow diagram. But again, this is just a high level idea of creating a project that is able to develop flow diagrams. My suggestion, if this does interest you, reach out to someone who might know more about creating diagrams than you do. Reach out to a subject matter expert that can definitely help and maybe provide better instructions to these agents so that the diagram can become more robust, more insightful, more informational, so forth and so on. But anyways, if you like what you see, if you like what you learned, please hit that subscribe button. Please make sure to comment, like, or dislike, make suggestions, have feedback. If you have suggestions on maybe what the instructions should be for these AI agents, throw it in the comments section. Let us all learn from you. Let us all take in your suggestions. I'm a firm believer in knowledge sharing, and I hope you are too. Um, but, anyways, I hope all of you have a great week. And you'll see me in the next video. Bye bye.